Bismillahirrahmanirrahim. Assalamu alaikum, dear students. In my last lecture, we have learned to evaluate integrals using substitution method. Now today, we will find integration of trigonometric functions using trigonometric identities. We know integration of sine x is minus cosine x and integration of cosine x is sine x. Now if we have to integrate sine square x or cosine square x, then for sine square x we will use the formula 1 minus cos of 2x divided by 2, and for cosine square x we will use the formula 1 plus cos of 2x divided by 2. Let us evaluate an integral using this method. Here we have to find integration of sine square 2x plus 5. We can write sine square 2x plus 5 as 1 minus cosine of twice 2x plus 5 whole divided by 2. That is further equal to integral of 1 by 2 minus cosine of 2 into 2 is 4, so it is 4x plus 2 into 5 is 10 divided by 2 dx, or we can write it as integral 1 by 2 dx minus integral cosine of 4x plus 10 divided by 2 dx. Now integration of 1 by 2 dx is 1 by 2x minus this 2 is constant, so we can write 1 by 2. Integration of cosine 4x plus 10 is sine of 4x plus 10 divided by differentiation of 4x plus 10 is 4 plus constant of integration c. That is further equal to 1 by 2x minus 4 into 2, that is 8, so it becomes 1 by 8 sine of 4x plus 10 plus constant of integration c. That completes the question. Now if integrand is product of sine and cosine functions, and sine and cosine functions have same angle, as in this case the angle is ax, so we put cosine of ax or sine of ax equal to some other variable, say t. So we can use this substitution to evaluate such integrals. Now if integrand is product of sine and cosine functions such that sine and cosine functions have different angles, as in these three cases. In case first we have sine ax cos bx, in case second we have sine ax sine bx, in case third we have cos ax cos bx. To evaluate these integrals, we will multiply and divide each integrand by 2 so that we can use a suitable trigonometric identity from the set of these trigonometric identities. Now let us evaluate an integral using this technique. Here we have to find integration of sine 3x cosine 4x. Now we can write it as 1 by 2 integral twice sine 3x cosine 4x. If we treat 3x as a and 4x as b, then we can use the formula twice sine a cos b, that is equal to sine a plus b plus sine a minus b. So we can write it is 1 by 2 integral sine 3x plus 4x plus sine of 3x minus 4x. That is further equal to, it is 1 by 2 integral sine 3x plus 4x, that is 7x, plus sine 3x minus 4x, that is sine minus x. Or we can write it is 1 by 2 integral sine 7x dx plus 1 by 2 integral. Now sine of minus theta is minus times sine of theta, so we can write sine of minus x is minus sine x dx. That is equal to 1 by 2 integration of sine is minus cosine, so we can write minus cosine of 7x, then differentiation of 7x is 7, so we have to write 7 here, plus 1 by 2 integration of sine is minus cosine, so it is minus cosine, then differentiation of x, that is 1, plus constant of integration c, or that is equal to 7 into 2, that is 14, so we can write minus 1 by 14 cosine of 7x minus plus, it is 1 by 2 cosine of x plus c. That completes the question. Now, if exponent of sine and cosine function is an odd natural number, then we can write these functions as sine x raised power 2n into sine x and cosine x raised power 2n into cosine x, or we can write them as sine square x whole raised power n into sine x and cosine square x whole raised power n into cosine of x. Now instead of sine square x we write 1 minus cosine square x, and instead of cosine square x we write 1 minus sine square x. From here we can use substitution method. In first integral we put cosine of x equal to t, and in second integral we put sine of x equal to t. Now let us use this technique to evaluate some integrals. Here we have to find integration of sine cube x. We can write it as sine square x sine x dx. Sine square x into sine x, that is sine cube x. But that is further equal to, instead of sine square x we can write 1 minus cosine square x into sine x dx, as we know that 1 minus cosine square x is equal to sine square x. Now put cosine of x equal to t, differentiating t with respect to x, we get dt by dx is equal to minus sine x, differentiation of cosine is minus sine, or dt is equal to minus sine x dx, or we can write minus dt is equal to sine x dx. Now substitute these in this integral, we get integration of 1 minus, instead of cosine we put t, it's t square, then we have sine x dx. Instead of sine x dx we put here minus dt, so put minus dt. Let us write minus here. So that is equal to minus times integration of 1 dt, that is dt, minus minus is plus, integral t square dt, that is further equal to minus times, now integral dt is equal to t plus integration of t square is t raised to power 3 divided by 3 plus constant of integration c, that is equal to, now t is equal to cosine of x, so we can write instead of t we have cosine of x, so it is minus cosine of x plus 1 by 3, it is t cube, so we can write cosine of x cube or cosine cube x plus constant of integration c. That completes the question. Now let us evaluate one more integral using this technique. Here we have to find integration of sine raised to power 7x. So we can write it as integral sine raised to power 6x into sine x dx. Or we can write it as integral sine square x raised to power 3 sine x dx. Now instead of sine square x we can write 1 minus cosine square x. It is 1 minus cosine square x whole cube sine x dx. Now we put cosine x equal to t. Put cosine x equal to t. Differentiating t with respect to x, we get dt by dx equal to minus sine x, as differentiation of cosine x is equal to minus sine x, or we can write minus times dt is equal to sine x dx. Now substitute these in this integral, we get integral 1 minus, instead of cosine we have t, so we write here t square whole raised to power 3. Instead of sine x dx we have minus dt, so we write dt minus times, let us put minus here, okay, that is equal to minus times, this is a minus b whole cube, that is a cube 1 cube minus b cube, so it becomes minus t raised power 3 into 2, that is 6, minus 3a square b, it is 3, a square, 1 square is 1, b, that is t square, plus 3ab square, a is 1, and b square, that is t square whole square, that is t raised to power 4, dt. Or we can write it is minus times integral 1 dt, that is dt, minus minus plus integral t raised to power 6 dt, minus minus again plus, it is integral 3 t square dt, then minus plus is minus integral 3 t raised to power 4 dt. That is further equal to, now this is minus times integral dt, that is equal to t, plus t raised to power 6, that is t raised to power 6 plus 1, that is t raised to power 7 divided by 7, plus 3 is constant, it is integration of t square is t raised to power 3 divided by 3, minus again 3 is constant, integration of t raised to power 4 is t raised to power 5 divided by 5, plus constant of integration c. Now we can replace t with cosine of x, so we get it is minus times, instead of t we have cosine of x plus 1 by 7, it is cosine raised to power 7x, 3 by 3 is 1, so we have plus t cube, so we write cosine raised to power 3x minus 3 by 5 cosine raised to power 5x plus constant of integration c, or we can write 1 by 7 cosine raised to power 7x minus 3 by 5 cosine raised to power 5x plus cosine raised to power 3x minus cosine of x plus c. That completes the question. I will continue this topic in my next lecture. Till then, take care of yourself. Thank you.